Photosynthesis will require energy in form of heat, which comes from sunlight. So it's the sunlight that energizes the chlorophyll. Remember, in photosynthesis, you have the dark stage, you have the light stage. So in the light stage, the chlorophyll is energized as a result of the energy coming from the sun. So the energy in form of heat comes in before the reaction occurs. So that is another reaction. So this reaction, we classify them into two, which we are going to look at. So those ones that release heat and those ones that needs heat before they occur. So in chemical reaction, energy is either absorbed, like for example, photosynthesis. So in photosynthesis, energy is absorbed from the sun, while sun releases energy, always in form of heat. Respiration release energy when oxygen acts on glucose. So this energy, the energy that is released, is usually as a result of breaking and forming of bonds. Breaking and forming of bonds. Remember, in a chemical reaction, you have your reactants, which are entirely different from your products. So the reactants are entirely different from the product. So the bond between the particles will be different. So before a chemical reaction will occur, the bonds, the chemical bonds that hold the reacting particles will have to be broken, and new bonds that will form products will have to be formed. So in a chemical reaction involves the breaking and the forming of chemical bonds. Teresa, you're raising your hand. Okay, so for some reaction will occur by taking heat to break the bond, while some, the breaking will release heat. So when energy, so in the study of this, the study of heat changes fall under a branch of chemistry that is called thermochemistry. So when you look at the relationship between chemical reactions and heat energy, so how heat energy makes some reaction occur and how heat energy is produced as a result of some chemical reaction. So when energy is transferred to the surrounding, this is called exothermic reaction. So we're talking about a reaction that releases heat to the surrounding. When that reaction occurs, it releases heat to the surrounding. Respiration is an exothermic reaction. Energy is released to the surrounding. And when energy is taken from the surrounding, we call it endothermic reaction. Photosynthesis. Photosynthesis, we take energy from sunlight. We take energy from sunlight. That's endothermic. So endothermic, we take energy from the surrounding. That means the reaction will absorb energy. But in exothermic, the reaction will release energy. So that is what we're trying to show you. So in the breaking of bond, energy needed to overcome the bond. So it will come in, will break the bond. Then when the bonds are being made, energy is given out. When the bonds are being formed, energy is given out. So in terms of heat, reactions that releases heat to the surrounding, they are exothermic reactions. While reactions that take heat from the surrounding, they absorb heat from the surrounding, they are called endothermic reactions. Do you understand that?
Yes.
Now, endothermic. So we have said that endothermic reactions, they take heat from the surrounding. That is, they absorb heat. Exothermic, they release heat. Please, can we mute our mic?
Lovely, mute your mic now. What's happening?
Idiot.
Lovely, what's happening now? You.
Can we move on?
Sir, should be
Please, can we mute our please?
Me. Sorry, now.
Some people just they use code, they don't know the rules of using code.
Yeah. I'm not supposed to be here. Sorry. It's actually like me, it's not working. No. I don't put my ear for fashion.
Hello, we're wasting our time.
It's not working, it's not charging.
Hello?
So we
Can
can
you
hear
hear
you.
me?
Yes, sir.
So we said endothermic reaction, we absorb heat from the surrounding. Exothermic, so you can be using photosynthesis respiration, just for you to remember. Photosynthesis will take energy from the sun, so it absorbs energy from the surrounding. Exothermic, we release heat from the surrounding. So endothermic and exothermic reaction can be thought as having energy as either a reactant or a product. Energy as either a reactant or a product. Endothermic reactions require energy, so energy will be a reactant. Photosynthesis requires energy from the sun, so it's an endothermic reaction. Heat flows from the surroundings to the system. So the energy comes from outside the plant, which is the sun now, into the plant. Then the enthalpy of the system increases. That means when you say enthalpy refers to the energy of the system. That means as the energy from the sun enters into the system, the energy will increase. The energy of it, because you now have external energy coming in, the particles themselves, they have their energy. So when an external energy comes in, the energy is increased. So that's why we say the enthalpy increases. So enthalpy is H. So we say delta H is positive. The energy will increase. Then exothermic reaction. Okay. For exothermic reaction, heat is released, considered as a product. That's respiration, and energy will be released in respiration. And that's the energy that you need to carry out some of your daily activities. So heat is released, considered to be a product in an exothermic reaction. So as it is released from the system, the energy of the system becomes lower. So the enthalpy change will be negative. So in the endothermic reaction, so we still see what enthalpy is, but let's just note that for now that enthalpy is positive, enthalpy is negative. For endothermic, so two things now for each. Endothermic, we absorb heat from the surrounding, and the enthalpy change, that is the total energy now will increase. So the enthalpy change becomes positive. Exothermic, heat is liberated or released to the surroundings. So the enthalpy change decreases. That is negative. Do we get that? So those are two things for endothermic and endothermic reaction. So now let's see more about them now. So what can we say more about endothermic reaction? So this is what happens. You can see the diagram here. So this is what happens in an endothermic reaction. Heat comes into the system. I see the arrow represents heat entering or energy entering into the system. So remember we said the enthalpy change is positive. So which means the enthalpy change is greater than 0. So in an endothermic reaction, the products, they have more energy than reactants. That's because energy has entered into the system. So the energy of the product will be higher than that of the reactant. So endothermic reaction, the products, they have higher energy. Then energy is absorbed. We have talked about that. It requires a higher activation energy. So I'm going to show us that in the diagram. We said that activation energy is energy barrier. So in an endothermic reaction, a higher activation energy will be required. Then if you touch the vessel of an endothermic reaction, it should be cold because it's absorbing heat from the surrounding. So the vessel will be colder to touch. When you touch the vessel of a reaction that is endothermic, it will be cooler. It will be cooler. So example, photosynthesis, I've talked about that. Melting of ice So if ice will melt, it will take heat from the surrounding. So it is heat from the surrounding that melts the ice. And that's why as long as the ice remains in the freezer, there is no source of heat that will melt it. But once you take it out, there is a new temperature now, it's a new surrounding. So the heat from the surrounding melts the ice. So that's endothermic. Then thermal decomposition of calcium carbonate. When calcium carbonate decomposes thermally, it needs it. You need to add energy. Most decomposition, thermal decomposition, they are endothermic because energy will be needed for the reaction for the substance to decompose. So these are some. So
All these questions
what is
I
it?
don't understand. So some people are just unmuting themselves and making the class kind of echoing.
Please, if you are not talking, and I don't think I'm asking anybody any question, so please, all mics should be muted. So for endothermic, remember, the products, they have higher energy because energy has come into the system. So the energy of the product will be higher than the reactant. The energy is absorbed, requires a higher activation energy. The vessel will be cooled to touch. So for exothermic reactions,
I have a question.
Okay.
AC, the work of our AC, can we call it endothermic reaction?
An AC will take heat from the surrounding. Okay, because it's taking it from the surrounding, endothermic. But sometimes AC can also release heat when the temperature is lower than required. I hope you know that.
That's exothermic.
So for an exothermic reaction, heat is released to the surrounding. So what you have left will not be of lower energy. So the reactants, they have more energy than the products. Because the products, some energy has been released out. So you have a lower energy. So the product will have lower energy. So heat is released. The activation energy is lower in endothermic reaction than in endothermic. So the vessel will feel warmer to touch. I don't know, maybe you have experienced something like this before. If you put some detergent in your hand and you add small amount of water, you will see that your hand will feel warm. When you add water to detergent, your hand will feel warm. It is produced from that reaction of adding water to detergent. That's an exothermic reaction. It is produced. So the vessel will be warmer to touch. So when you touch, it will be warmer. So example, combustion. Combustion is an exothermic reaction. Respiration is an exothermic reaction. Neutralization is an exothermic reaction. Corrosion, I talked about corrosion before. So corrosion is also an exothermic reaction. So all this heat is released. We have some other ones. The solution of H2SO4 in water. If you add water to H2SO4, it is produced. It's also an exothermic reaction. So remember, endothermic reaction will absorb heat from the surrounding. Exothermic reaction will liberate or release heat to the surrounding. Did you get it? Okay.
Yes, sir.
Okay.
Yes.
So who said he asked questions there? I can't hear you.
Now, what point of you say that the exothermic reaction, energy more in the right side and the flow side, right?
What is it?
In an exothermic reaction, energy is more the reactant side than the product side.
Yes, that's what we said. Yes, that's the energy of the product.
What of
Lower than
the
the energy
endothermic
of the
reaction? What time in the atomic reaction.
The product to be higher. The energy of product is higher.
No, because heat is being given out. There's a atomic. Yeah.
It is given out in exothermic, so you are left with less energy. So the product will be lower. Do you get that?
Yes, sir. So does that mean reaction energy in endothermic is higher than exothermic?
Yeah. For the activation energy is higher. So the particles, they will need more energy to occur in endothermic than in exothermic. Most of the reactions that we have are exothermic. Most reactions are exothermic. We have more exothermic reactions than. Okay, so because of time, I will not start energy provider. I think we have class tomorrow. So tomorrow we look at energy provider again. So any question?
Sorry.
Convey the topic.
What is it? I said heat of reaction, heat changes in chemical reaction, or thermodynamics, thermochemistry.
So is this note on the app?
No, I'm not done with it. I still want to ask you. I still want to add entropy, deep stage. But you should get it first.
Okay,
So see you up tomorrow. Thank you.
Good night, sir.
Thank
Thank you, sir. Thank you.
All right, thank you very much, sir. Let me greet you specially.